Students, welcome back to our paper CHO 4103, that is Basic Organic Chemistry. Today we are going to start with a fresh topic, that is aromaticity. So friends, before I start aromaticity, let's discuss about some backgrounds about aromaticity. So friends, especially I will discuss the syllabus and what we are going to learn in this topic. Until your undergraduate course, you have learned about basic information about aromaticity and the Huckel's rule. But friends, in the BSc, you don't have much about the aromaticity. You just learn about some benzene related compounds and some heterocyclic compounds. In this year, we will learn about the aromatic compounds, anti-aromatic compounds and non-aromatic compounds. Also, we will extend the concept towards azulines, anilines and some more complex heterocyclic compounds. We will discuss about some important questions asked in CSIR NET examination, GATE examination as well as in SET examination. So this lecture series will be very important for your master course as well as for the competitive exams. So let's begin with the aromaticity and its background. So in the 19th century, it was recognized that aromatic compound differs greatly from simple unsaturated aliphatic compounds. So although they contain double bond, they have different type of properties, or they differ between simple olefin or unsaturated compound, and this is due to their have extremely high resonance energy, as well as it is observed that they undergo substitution reaction rather than addition reaction, and also have delocalized pi electrons. So friends, these three different types of observations they make the aromatic compound very distinct from the simple unsaturated compounds. So friends, there are four key criteria for the aromaticity. So I will directly start with the topic. As you learn this topic in BSc, I will not waste much time, or I will not take much time on the basics of aromaticity. So let's start with the what are the aromatic compounds, or what are the criteria for the aromaticity. As you know that first it must be cyclic, secondly the molecule must be planar, third will be the each and every atom in the ring must be conjugated, and fourth one is very popular, that is a molecule must have 4n plus 2 pi electron system. So friends, this lecture will be just a review for the BSc, or just I will review these four criteria for the aromaticity. So friends, let's start with one by one. So first is a molecule must be cyclic. Simply cycle means there should be a ring, or only the cyclic compounds will consider as aromatic. But don't go for the aromaticity just like that. We are just discussing the first criteria. The molecule must obey all the four criteria. So you can see here what is meant by cyclic. Just for the beginners, I will say this is a ring, or this is called as cyclic. This is acyclic. So anyhow, this first one will be the aromatic, second will be not aromatic. This is cyclic, this is a acyclic. So we can consider this molecule whether it will be aromatic or not. Again, this is cyclic, this is not cyclic. But friends, you will say that these compounds have also a ring system, but why they are not aromatic? Because we are just listening, or we are just observing first criteria. We need to consider all four criteria for single molecule or single compound. So just don't rush for the label of aromaticity with this one criteria. Let's see all the four criteria, and then we will discuss about the aromaticity and non-aromaticity. Okay, so friends, this is the first criteria. you are well known about the ring system. So the ring and or the cyclic and acyclic. This is the only thing I want to share with this slide. So this is a cyclic compound, this is a acyclic compound. So only cyclic compounds or for the aromaticity, the compound or molecule must be cyclic. It should be in the ring form. The next criteria is every atom in the ring must be conjugated. So sometimes we use the term fully conjugated. That means each and every atom in the ring must be able to participate in resonance. You cannot left behind any single atom in the ring for the conjugation. Then and then only it will be said to be fully conjugated compound. So you can see here, this is the lone pair and all the nitrogen, carbons and nitrogen in the ring are involved in the resonance. Therefore, it is called as a aromatic compound, or I will say fully conjugated compound. Don't rush for the aromaticity. This is a fully aromatic or fully conjugated compounds. Okay, this is a fully conjugated compound. This is not fully conjugated because nitrogen doesn't get any kind of delocalization. You can see here this carbon negative charge or negative charge on the carbon is distributed all over this ring. But if we have this kind of compound, this is not aromatic because, or I will say, this is not fully conjugated. Again, this is fully conjugated, this is not fully conjugated because this carbon is remaining from the conjugation. Again, here you can see this first one is fully conjugated, this is not fully conjugated because at any cost we cannot put this pi electron density over here. So this one is fully conjugated, but this is not a fully conjugated. So this is second criteria. First one was it must be a cyclic compound. We saw which are cyclic and which are not cyclic. Then second criteria, every atom in the ring must be conjugated, or the compound or molecule must be fully conjugated. So what is meant by fully conjugated? This electron density must be distributed to each and every atom in the ring, whether it is a carbon, oxygen, nitrogen, sulfur, any atom. So these compounds, the first one, this one, and this one, they are fully conjugated and others are not fully conjugated. So these are the liable for the aromaticity. Now next is the molecule must have 4n plus 2 pi electron system. Okay, what is meant by 4n plus pi electron system? Most of the students confuse between this 4n plus 2 pi electron system. So friends, what we need to do, we need to put n as 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. So it must be a whole number. It must be an integer number. So whole number. It should not be a fraction. So friends, whole number means 0, 1, 2, 3, 4, 5. Now if we know the n, we can calculate the number of pi electrons. So let's put n is equal to 0. So 4 into 0 is 0 plus 2 is 2. So 2 pi electrons. Again, if we put n as a 1, then it's a 4 into 1 4 plus 2 6. That means 6 pi electron. If we put 2, then it will be 10 pi electron. Then 3 will be 14 pi electron, 18 pi electron, 22 pi electron and so on. So these are the magic numbers which are responsible for the aromaticity. So if compound having the pi electrons 2, 6, 10, 14, 18, 22 and so on, then that compound is liable for the aromaticity if this compound obeys all the criteria of the aromaticity. Okay, so this is very simple. N, we need not to find n. N is any integer number like 0, 1, 2, 3, 4, and the magic number for the pi electron for aromaticity is 2, 6, 10, 14, 18, 22 and so on. So this is how we are going to consider the 4n plus pi electron system. Now you can see here. Now few examples are there. So simplest example is benzene ring. Benzene ring have 2, 4 and 6 pi electron system. It is easy to calculate. Now you can see here, this is the simple cyclopentadienyl anion. So it have 2 pi electrons, 2 pi bonds, 4 pi electron, and then this negative charge means again 2 more pi electron, that means 6 pi electron. This is have 4 pi electron. This positive charge doesn't have any electron, pi electrons, so this is only 2 pi bonds, that means 4 pi electrons. Again this one have only 1 pi bond, that means 2 pi electrons, 10 pi electrons. So naphthalene 2, 4, 6, 8, 10 pi electron. This is a topolymine 6 pi electron. This is a cyclooctatetraene. So this have 4 pi bonds, that means 8 pi electrons, and so on. So this is how we are going to calculate the pi electrons. So what number we need? We need 2, 6, 10, 14, 18, 22 and so on. Like this we are going to search for the molecule. So again you can see here, this molecule have 10 pi electron, this molecule have 10 pi electron, this naphthalene have 10 pi electron. This is the magic number. So if this molecule follows all the 4 criteria for the aromaticity, then and then only they will say to be aromatic. Now let's go for the last but most important criteria, that is a molecule must be planar. So what is the planarity, or molecule must be flat? So you can see that the small rings like 3 membered, 4 membered, 5 membered, 6 membered, even 7 membered ring can hold all the atoms in one plane. But as we cross the 7, the 8 member, 9 member, 10 member, 11 member, these ring system cannot hold all the atoms in one plane. Therefore they are not planar. Even they contains 4n plus 2 pi electron, they are not considered aromatic because they are not a planar, they are not a flat structure. So you can see here, this molecule is 8 membered ring. What I said, from 8, 9 and 10 and 11, 8, 9, 10, 11, these are the ring systems which cannot hold all the atoms in one plane. If we cross the 11, then again from 12, the larger molecules, or I will say macromolecule, they again make all the atoms in one plane. But this 8, 9, 10, 11, they don't hold all the atoms in one plane. So as you know that this is not a planar structure, but it is a tub-like structure. So this is a cyclooctatetraene. So this is cyclooctatetraene, and this is not a planar, this is a tub-shaped structure. That's why most of the time we said this is not a aromatic compound. So friends, these are the 4 criteria. So I have again, for the last point, I have again this structure. So 4 membered ring, 6 membered ring, they are planar. So they are planar. So again, this is 8 membered ring, 10 membered ring. 8 and 10 membered ring are not planar. That's why they are not aromatic. Even look at this 10 aniline. N is integer number 2, but this is not planar. Okay, this is not planar. That's why it is not aromatic. This is a non-aromatic compound. So this is the mistake over here. It said aromatic, but these are the non-aromatic compounds, not aromatic compounds. Okay, 10 anilines as well as 8 anilines, they are not aromatic compounds. Please correct this mistake. This is a not aromatic compound. So these are the criteria for the aromaticity. First one was, I will again recall it. The first one was cyclic, second is planar, third is it must be fully conjugated, and fourth one must be it will have to obey Huckel's rule, that is the 4n plus 2 pi electron rule. So friends, this is a very nice book, very big book of organic chemistry, that is Advanced Organic Chemistry by Jerry March. So this is very helpful book for the concept of aromaticity. From this book, most of the questions from CSIR net or GATE or SET is collected, and we must follow this book or must refer this book for the concept of aromaticity. So friends, if you have any doubt regarding these four criteria, feel free to ask me. Thank you.